This next problem asks us how many grams of water will be produced from 50 grams of hydrogen and 100 grams of oxygen, and how much excess reactant will remain. So first we will start out by writing the chemical reaction. So how many grams of water will be produced? We are making water, that's going to be our product. From 50 grams of hydrogen, so one of our reactants is going to be hydrogen. I didn't leave room to balance here, so I'll go back. One of our reactants is going to be hydrogen, which I know is a diatomic, and the other reactant will be oxygen, which is also a diatomic. So O2 plus H2 gives me H2O. And it doesn't matter what order you write the reactants in. Since there are two of them, we can write H2 plus O2 or O2 plus H2. It doesn't actually matter here. So then we need to balance our chemical equation, and right away I notice that oxygen's out of balance. So to fix that, I'm going to put a coefficient of 2 in front of H2O. But that then throws hydrogen off balance, so I will also have to put a 2 in front of H2 on the reactant side. And now that everything's balanced, I'll go ahead and fill in a 1 next to O2 just to remind myself that a 1 is implied. So now we should start with our two given values and figure out which one of these reactants is going to be limiting. So 50 grams of hydrogen or 100 grams of oxygen. So we'll figure out which one of those amounts produces less water, and that will be our limiting reactant. So here we go. So 50.0 grams of H2. And we will start by converting our grams of H2 to moles of H2. Then we can take our moles of H2 and convert it to moles of product, so moles of H2O. And then we'll do the same thing for the 100 grams of oxygen, so 100 grams of oxygen. We'll take our grams of O2 to moles of O2, and then we'll take our moles of O2 all the way to moles of H2O. So now we just need to fill in some numbers. I'm going to start with the mole to mole ratio, and we'll pull from the balanced chemical equation here. So 2 moles of H2O. That's going to be the top of both of my mole to mole ratios. And then 2 moles of H2. So this top one's a 2 to 2 ratio. And then for O2, it's just 1 mole of O2. So a 2 to 1 ratio down here. Alright, so now that we've put our mole to mole ratios, we better do our mole to gram conversions. And I know that 1 mole is always equal to the molar mass of that particular substance. So for H2, that would be the mass of hydrogen times 2. So 1 times 2 gives us about 2 grams per mole. And then oxygen's mass of the oxygen atom is about 16. So in this case we have O2, so it would be 16 times 2, which is 32 grams per mole. And so now we'll just multiply this all out. So 50 divided by 2 times 2 divided by 2. So this gives us about 25. And we should keep a third sig fig, so I'm going to put 25.0 moles of H2O. And then on our bottom one, 100 divided by 32 times 2. That gives us 6.25 moles of H2O. And this actually only has one significant figure, so at the end we will have to round to one significant figure. But I'm going to leave it unrounded right now because we're not actually at our theoretical yield in grams yet, and the problem does ask us for grams of water. Okay, so let's label our limiting and excess reactants. So right away, the one that produces less is the oxygen. So right here, this is our limiting reactant. And then the reactant available in excess would be the hydrogen. So we'll cross off this 25 moles of H2O because we know we won't be able to produce that many. We'll be cut off by the oxygen running out once we have 6.25 moles of H2O. Now I'm going to take that moles and convert it to my desired unit of grams. So we'll take our moles of H2O and convert to grams of H2O. 1 mole of H2O is about 2 plus 16, so about 18 grams per mole. That might be one that you use so much that you kind of have it memorized. And so when I multiply 6.25 times 18, I get 112.5 grams of H2O. But of course I do need to round that to sig figs, and since we only started out with 1 sig fig in the 100 grams of water, we are actually going to have to round our answer to only 1 sig fig as well. And so I get to keep this first digit, and then it's going to stay a 1, so I'm going to round this to 1, and I'll fill in my placeholder zeros, 100 grams of H2O. That's our theoretical yield. I'll box that part in. This is our theoretical yield. And then it asks us how much excess reactant remains. So we need to figure out how much hydrogen was used up and then how much is left over. So I'm going to start with my amount in moles of my my product produced by my limiting reactant. So I'll start with 6.25 moles of H2O. Let's see, 6.25 moles of H2O, and I will go from moles of H2O to grams of H2O. Oh, sorry, not mole to grams of H2O. I don't want to go there. I want to go to how much hydrogen was used up. So from moles of H2O to moles of H2. And then from moles of H2 to grams of H2. And that will tell me how much hydrogen is being used or consumed in this reaction. So looking at our equation, for every 2 moles of H2, we get 2 moles of H2O. And we know that 1 mole of H2 is equal to approximately 2 grams of H2. And so when I calculate this out, I get about 12.5 grams of H2 that is used up. So all that remains to do is to calculate out how much is left over. So we started out with 50 grams of H2, but we weren't able to use all that. Sorry, random line there. So we'll start with 50 grams, or rather 50.0 grams. It does matter for sig figs here. And subtract out the 12.5 grams that were used up. And so here we end up getting 37.5 grams of excess. And this is excess H2, or hydrogen gas. And so I will go ahead and box in that final answer down here. So there is our amount of excess.